number 72, we have each face of a cube can be painted in black or white colors. In how many different ways can the cube be painted? Option A 9, option B 10, option C 11 or option D 12. 72nd question, they are asking us, say this is a cube. Each of its faces can be painted in black or white. So you know that there are two possibilities for each of the face. So you can't just write 2 into 2 into 2 until for 6 times, that is equal to 64. That's not in the option. So here you need a little bit of thinking, you need a little bit of imagination here. Here what happens is, you have a cube, okay? So if I paint this side, this face of the cube black, okay, so it is equivalent of painting this face as black. It's all relative how you see it, because cube has all the sides. In a cube, all sides are all faces are similar, are identical in relation to each other. Okay, so everyone, each of the face is having the same area, same dimension, and relative to each other, everything is same. So when you say there are, say for example, I have to paint only one of the face. Okay, so it will be, so how many possible combinations will I get? I'll have two combinations. Okay, either I can face it, I can paint it white, or I can paint it black. So when you are solving this question, you can't just use the normal method. What method I will use is, I will assume that by default everything would be painted white. Okay, so this is by default, everything is painted white. Okay, so let's get into some situations when black face is 0. The white, all of the faces have to be painted, all 6 faces have to be painted white of the 6 faces of the cube. Okay, so that is one positive. That's very easy to understand. Everything is white. You can do it only in one manner, only in one fashion, one manner. Okay, they are saying how many different ways can the cube be painted? Only one, when black is 0 and white is painted for all the faces. When black, only one face is painted black, it means any of the face. Okay, there is no distinction between this face or this face, because everything is relative to each other. So white is 5. You have only one possibility again. When black is 2, when 2 faces of the cube are painted black, you have some relativity there. This is a relativity problem. Either it can be 2 opposite faces, this and the one behind, or it can be 2 adjacent faces, this and this, say for example. Okay, so these 2 are adjacent faces, or it can be like that. So say you say that no, I won't paint like this, I will paint this face and this face, one at the top and one at the side. But then if I turn the cube like this, then it's also an adjacent face. So although it appears that these are 2 different ways of painting, but it's not. The moment I change the cube, the orientation of the cube, the relativity tells me that it is same as painting 2 adjacent faces. And again, we say that I will paint this top one and bottom one. It is, when you change the cube like this, it's nothing but front and back. So there are only 2 ways you can paint the cube when you paint 2 faces as black. Now when you paint 3 faces as black, what happens is, however you paint the 3 faces black, say you paint 2 opposite faces and 1 adjacent face, you are getting a strip like this, strip of 3 faces, 1, 2, 3. However you do paint like this, say like this. Okay, so you have this option as well, that is painting in such a way that you find a strip, or you will find something, 2 adjacent sides, and the face and 1 face which is common to these 2 adjacent faces. Okay, like they need to have a 3 meeting point. It's like you're taking a corner, and all the faces which are adjacent to this one particular corner, you're painting it. So this is one possibility when you're painting the black thrice. Or if you try to paint it in some other manner, however you paint it, you will get a strip like this, 1, 2 and 3, like this. Okay, you are painting say this, this and this. Again, you will find a strip like this. So these are the only two ways in which you can paint. All the things which are into a corner, this face, this face, this face, or the strip manner. It needs a little bit of thinking, a little bit of imagination. So you will end up with only two such possibilities. When you paint all the faces black, four faces black, see again only two whites will be left out. The two whites which are left out, you can compare it with painting two blacks. It can be those two whites which are left out will be either opposite or adjacent. However you try to imagine it, it will come only in these two possibilities. Okay, either they will be opposite or they will be adjacent. It is similar to this one. So you will end up with only two possibilities. When you paint black 5 times and white only once, again you have left out only one white. Okay, so that can be anywhere. Okay, so it's all relative. It's only one way you can do it. And when you paint black 6 times, obviously you know that only one way you can do it. So I write 1 here. Now you just have to total all these numbers which you have got. 1 plus 1 is 2, plus 2 4, plus 2 6, 8, 9 and 10. So 10 is the right answer. I have seen many videos explaining this problem, but nobody has explained it in a right manner, I feel. So, but somehow they have reached 10 as the answer. I don't know how. Some people have just done 2 plus 2 plus 2 and reached 12. This problem needs a little bit of imagination, as I said. Painting one face is equivalent to painting any face, because a cube is a relative, it's a relative figure. There is no, say in a right angle triangle, you identify the sides. You say that, okay, this is right angle triangle. This cannot be this is the side which is opposite to right angle triangle. You can't say that suddenly, okay, this side has become that, this side cannot take the place of this side, okay. But in a cube, every face is identical. So painting this face, if I reverse it, then it's like painting this face, the bottom face, okay. So everything is relative. That's how this problem is supposed to be solved.